Okay guys, so today we're going to be looking at section 7.2, modeling with linear equations. Okay, so several things we're going to look at are in this chart. So the first thing is to write the equation in standard form. So I'm going to put a little note over here. If in slope intercept form get x and y on the same side. Put the x term first. Okay, so I'm going to do an example of this right up here. So if I have y equals 3x minus 5, I'm going to need to move my 3x over, so that becomes negative 3x plus y equals 5. And now it's in standard form. Okay? Alright, next, state the x and y intercepts of the graph of the equation. So, what we need to do, these are the x and y intercepts of this equation right here. But how do we find those? To find the x-intercept, we let y equals 0. So if we let y equals 0 here, this goes away. So we divide 3 into 6, and that's 2. So your x-intercept would be 2, 0. Then here, to find our y-intercept, we let our x be 0. So when we plug in 0 here, this makes this go away. You divide 2 into 6, and you get 3. So y is 3. So there you go. Alright, but I'm going to do it with this problem right here. Okay, so we're going to come up here and do this right here. So negative 3x plus y equals negative 5. So if we're finding the x-intercept, okay, we're going to let y equals 0. So we do negative 3 plus 0 equals negative 5. So negative 3x equals negative 5. So x equals positive 5/3. So our x-intercept would be 5/3, 0. And that would be our x-intercept. Then to find our y-intercept, we let x be 0. So this time, we plug in 0 for x, and we get y, 0 plus y equals negative 5. So y is negative 5. So our y-intercept would be 0, negative 5. Okay? Now, the last piece here, specify the slope and the y-intercept of the graph of the equation. Alright, so let's come over here and put a note. If it is in standard form, get y by itself, then pull out slope and y-intercept. Okay, so right here, we're going to deal with the problem that we've been dealing with. So let's look at the problem that they gave us. So if we're trying to get it in slope-intercept form, we're going to move the 3x over by subtraction and divide by 2. So that gives us negative 3/2 x, and when we divide 6 by 2, we get 3. So our slope is negative 3/2. Our y-intercept is 3. So let's try it on this problem. So this time we're going to move the 3x over. So we have y equals positive 3x minus 5. Okay, so your slope, which remember is your m, is 3, and your y-intercept, which is your b, is your negative 5. Okay, now the next problem that they want us to work is find a linear equation of a line with a slope of 3 and passing through the point 4, 5. So they told us that the slope is 3, so this is our m. Okay, and we're passing through the point 4, 5. So if they give you a point, remember in a point, the first number is your x, the second number is your y. So let's start with slope-intercept form, y equals mx plus b, and plug in what we know. Well, we know y is 5, we know m is 3, we know x is 4, so that means we need to find our y-intercept. So this is going to be 5 equals 12 plus b, so we move the 12 over, and we get negative 7 equals b. Now, to write it in slope-intercept form, remember we write y equals m is 3, x plus b. So the plus the negative 7 would be like minus 7. Okay? Now, if they want it in standard form, all they want you to do is move this x term over. So when I move the x term over, it becomes a negative 3x. Then you still have the y equals negative 7. And this would be your answer. Okay. Example 2. As a part of a settlement of lawsuits against tobacco companies, the U.S. government required cigarette manufacturers to pay for anti-smoking education programs. Assuming that as a result of such programs, the smoking rate among 18 to 25-year-olds is dropping at a rate of 0.6% a year. Okay? Anytime it talks about a rate, that's your slope. Okay? And that after 3 years, the smoking rate is 38.8%. Okay? If we model this reduction by a linear equation, what would we predict the smoking rate to be in 10 more years? So there's 2 parts to this. Okay? So the first part is to come up with the equation using the information that we highlighted in yellow. And the second part is to predict the smoking rate in 10 years. Okay? So here we go. This is the way we're going to do this one. So the first thing that they gave us is that our slope is dropping. So that means it's negative. It's negative 0.6. Then our ordered pair that they gave us is 3 and 38.10. 38.8, excuse me, 38.8. So plug this in like we did just a few minutes ago into y equals mx plus b. So y is 38.8, m is negative 0.6, x is 3. So here we have 38.8 equals negative 1.8 plus b. Then we're going to move this over so it becomes addition. So you add 1.8 to 38.8 and you get 40.6, and that's your y-intercept. So remember, our equation then is going to be y equals negative 0.6x plus 40.6. Now, it asks us here in 10 more years. So how many years has it been? Because it says after 3 years, then in 10 more years. So we do 10 plus the 3, so they want to know in 13 years. So this is our x value. They want to know what y is going to be. So you're going to plug in 13 in for x and solve for y. So 13 times 0.6 is negative 7.8. Then we're going to add it, well, plus 40.6. And that's going to give me 32.8. So the answer, the smoking rate, is 32.8%. Okay, next problem. Find the equation of a line passing through the points 4, 2, and 8, 5. So in the past, they've given me slope and 1 point. This time, they're not giving me a slope. They're giving me 2 points. So the first thing I need to do is find my slope. Remember, I subtract my y's over subtracting my x's. So I do 5 minus 2 over 8 minus 4. So that's going to be 3/4, which is 0.75. Okay. Then, so now I know I have the slope of this. Now I just need to pick one of the points. Now I'm just going to pick the first one just because it's first. Okay, and now it's like the problems we've been doing. So we're going to plug in to y equals mx plus b. Y is 2, m is 0.75, x is 4. So 0.75 times 4 is 3. So now we're going to move the 3 over, and that becomes a negative 1. So remember, when we write our equation, we write it with our slope, which is 0.75 minus 1. And you could leave it in fraction form if you wanted to and make that 3/4 x minus 1. Okay. Next example. Rachel's selling gourmet cupcakes on the internet. In the 4th month of operation, she sold 480 dozen cupcakes. In the 7th month of operations, she sold 792 dozen. Assume we can model the increase in her business by a linear equation. She estimates with her current equipment she can make a maximum of 1,500 dozen cupcakes per month. If she wants her business to keep growing, during what month will she exceed her current capacity to produce baked goods? All right, so there's two parts here. We work with these things, and then we got to find out when she'll hit that maximum. Okay, so here we go. So 4th month, so that's 4. She's baking 480 dozen. In the 7th month, she's baking 792 dozen. Okay, so we know what to do. We have to find our slope. Okay, so we do 792 minus 480 over 7 minus 4. And that's 312 divided by 3, which is 104. So that's our slope. So we have y equals mx plus b. We know that our m is 104. And we're going to pick a point, so I always use the first one just to make it easier. So plug them in. So the y is 480, the m is 104, the x is 4 plus b. So we have 480 equals 416 plus b. We move the 416 over, and 64 is b. So we have y equals 104x plus 64. Now, she wants to know when she can hit 1,500 dozen. So that means that our y is 1,500. Okay? So we hit 1,500 dozen when? So that goes in for our y, and we solve for our x. So we're going to move our 64 over. Get our 1436. And we divide by 104. And you get 13.81 months. But you can't have part of a month. So when is this going to happen? In her 14th month. Okay. All right. Now let's look at a problem using some graphs. So figure 7.8 shows a graph of digital music and music video sales for the years 2005 to 2008 in billions of dollars as reported by the Recording Industry Association of America. Although these points do not quite lie on a straight line, we may still wish to model these data with a linear equation. Model these data by finding the equation of a line passing through points A and B. So if we're looking at A and we're looking at B, okay, if we're looking at those 2 points, A is located at 2005, comma, 0.5. B is located at 2008, comma, 171. So we're about to write the line. Okay, so the first thing we're going to do is find our slope. So we do 1.71 minus 0.5 over 2008 minus 2005. So that gives me 1.21 divided by 3, which is 0.4. Okay? Now, so this means that our slope is 0.4. Remember, I always use the first point. So 2005 and the 0.5. So we plug in where they go into y equals mx plus b. So the y is 0.5, the m is 0.4, the x is 2005 plus b. So this is 0.5 equals 802 plus b. So this is negative 801.5 equals b. So my equation is y equals 0.4x minus 801.5. Then it says use this model to predict music sales in 2009. So we know that X is our year, so we want to know when X is 2009, what is Y? So Y equals 0.4 times 2009 minus 801.5. When you type this into your calculator, you're going to get 2.1, and this is in terms of billions. So this is $1 billion. Okay. The actual digital music sales in 2009, so this was a projection, were 2.03 billion. Evaluate the accuracy of this model. So we're going to say our prediction was a little high. Therefore, we should be careful when using this model for long-term predictions. And the reason why it's not exactly on the money is because it says it's not quite a straight line. So these predictions are not going to be quite right because this is a linear model and this isn't quite a linear line. And you may remember back from Math 1 that when you have not quite a linear line, you found something that was called finding the line of best fit. Now, I don't like the way they do it here, so we're going to write our own step. So, we're going to make our own table. But the first thing that we have to do before we start, step 1, you need to turn on diagnostics. You're going to go and you're going to hit second and the 0. Scroll down to, it's going to say on, and you're going to hit enter and enter. Okay, so if I go to my calculator, all right, and I'm going to go second 0, which is the catalog. They're in alphabetical order, so scroll down till you get to diagnostics on, enter, enter. You might only have to hit enter once. It depends on if you have an old calculator or a new calculator. All right, then step 2. You're going to go to Stat. Write this down first before you start. And you're going to go to Edit. Then you're going to hit Enter. Oh, Stat, Edit, and then you're going to enter in all ordered pairs. And you're going to enter them into L1 and L2. If you don't have L1 and L2, you need to restart your calculator to reset your stuff and then turn your diagnostics back on. So we're going to Stat, which is right here. Hit enter for edit, and I've got some numbers in here. So we're going to go 2005. We're typing in these ordered pairs. Oops. Hit enter. 2006, enter. 2007, enter. 2008, enter. Then we can delete that one. I'm going to delete that one. Then I go up and I'm going to type in 0.5, 0.88, 1.26, 1.71. And I would go through and double check to make sure all of them are right. Okay. Then, to get our actual equation, we had to give it the numbers that it was working with. We're going to go to Stat, over to Calculate, option number 4. Then we're going to hit Calculate, or go down to Calculate if you have a new calculator, and hit Enter. And then you should see something that looks like this. So we're going to go to Stat, over to Calculate, option 4, which says Linear Regression. Go down to Calculate, hit Enter, and if you look, you should have, our numbers here is different because we typed in the actual years. Here they used year 0 for 2005, but it's fine. So our equation is 0.401 minus 803.519. So our equation was just a little bit off in both the slope. Oh, this should be x. Okay. A little bit off for that. Now, let's just look at this. We can use a technique in statistics called linear regression to find a line of best fit. The linear regression coefficient, which is the R that they give you, measures the strength of the linear relationship between S and T. The closer to 1 that R is, the closer it is to being a straight line. So this is 0.99999. So that's a really strong, close to a straight line. If you have like a 0.01, that's not close to a straight line at all. So you can look and see how close you are to being a straight line for this. So I want to put right here, close to 1, good fit. Close to 0, bad fit. Alright guys, and that's all for today. If you have any questions, please feel free to reach out. You can watch this video as many times as you need, and hope you have a great day.